try again. Good evening. Thank you. Thank you. My name is Ken Wolf. I'm the Dean of the College of Science and Health, and I want to welcome you this evening. You're in for a treat. We have with us tonight Jason Kendall. Jason Kendall. I always do that.
It's okay. That's because when we first introduced, I told you how to remember, which is end all the fun.
Yeah, absolutely. The way that starting over again. We have an opportunity to have not only a learning experience, but an entertaining experience. Our speaker tonight has academic credentials in both astronomy and in the theater, having trained in the Southwest at New Mexico and in Texas, and then coming to New Jersey. Let me ask you, how many of you in the audience are alumni from William Patterson University? Welcome, and thank you for coming back and supporting the university. And how many of you are students?
Hey, now that's how we roll.
Great. Well, those of you that are students know what you're about to experience, and those of you that are here for the first time, sit back and relax and be prepared to learn something and to also enjoy as we talk about the battle for the planet of Pluto.
Thank you. Welcome. Thank you all. Just so you know what we're going to do tonight. Tonight is an interesting night because Pluto causes so much controversy all over the world. And there's no question, since its discovery back in, I'm going to turn this off because I use stage voice. That's what I went to theater school for. So when you actually look at Pluto, it caused so much controversy and has done so since its discovery in the 1930s. So most recently, and even still, there are people that are completely going nuts over the recent IAU decision. And there's reason for that. There's actually quite legitimate reason for why the IAU did what it did, and the people who really disagree with it. So it's an active subject of debate, and there's nothing that we like more in any aspect of science than to actually see the discovery portion and the debate in action. And Pluto, in the scientific community today, embodies that. So, what we're looking at today, this is NASA's version of a wonderful piece of software that you can get downloaded for free called Eyes on the Solar System. I'm showing you what the New Horizons mission looks like. It's a little bitty spacecraft on its way to Pluto. It was launched in 2006. It's about this big. That's all big it is. It's about the width of a piano. That's not very big. That dish is only about yay big. It's a little thing. And it's cruising along, and let's see what the current speed is, at 32,000 miles per hour. That's its current speed. Now, you see any jets on that thing? Let's look around. Okay, let's look around that thing and take a swing around it. This is the actual thing. Oh my goodness, what does it look like? How's it with 32,000 miles without jets on it? That's a really good question. And the answer is, Mr. Newton is driving it. The old Newton's laws are driving it. Momentum, there's nothing to slow it down, or practically nothing to slow it down, very little. So it's coasting at 32,000 miles an hour, which means in the time that I just started, it's gone over 200 miles, more like 100 miles. By the time this evening is done, it will have gone tens of thousands of miles. It's going so fast that we're in Atlantic City. That's pretty fast. That's a nice, wouldn't you like to get to AC that fast, you know? And maybe that casino would be closing if that's the case. So, the thing is, we actually get there. So if we actually speed up time and see what we get, let's actually cruise through and see what the encounter looks like. Oh, it spins so fast, but look where the time is. September 22nd this year, let's keep going fast. Uh-oh, wait a second. How long is it going to take to get there? We're still going 32,000 miles an hour. Look at the days cruise by. Oh my gosh. I'm going to slow it down a bit. Oh, wait, I think we went past it. Go back. Oh, there we go. So, Pluto's coming into view. So, look at this. It was launched in 2006. And at the time it was going so fast at 17 miles per second, roughly. Let's see if I can bring it up a bit. Come on, speed her up. July 6th.
He's prepared.
I want to show you the count. Oh, wait, July 13, there we go. Hold down. So the current rate, the real rate. So it's at July 13th of 2015. Let's actually cruise forward a little bit faster. Not too fast this time, because we don't want to go too far by it. Because on the next year, in July, it's really a tweaky piece of programming, ain't it? If I get it going, there it goes. Oops, right, really, right about now. Here we go. We've got a real date, July 14th at 4 o'clock in the morning Eastern Standard Time. It begins its approach and cruises by Pluto, going 32,000 miles an hour, and hopefully, I did. What the heck? That's what it's going to do. It's going to just keep going. Now, sometimes people when a spacecraft encounters some kind of distant place, it lands, it puts down something, it goes by, no, it's going to right by. Where's it going to go? It's going to keep going forever and ever and ever. Space is big. Things are small. There ain't nothing to hit. Yes.
I'm glad there are no humans on that.
Yes, but in effect, there are. And I'll tell you what I mean by that later. So let's get out of here. Let's see. All right, awesome. We'll drop out of here. I'll let you guys look at that another moment. Yes, I really want to quit. Unfortunately, very cute. I'll tell you what I mean by that. And I'll kill the iTunes because that's just going to be irritating. All right, and we're at. Let's go slide. So, the battle for planet Pluto. In the hearts and minds of young and old Americans, people like me who grew up with 9 planets. And yes, since I knew Clyde Tombaugh, I met him. I was in graduate school in New Mexico State when Clyde was there. He's my guy. I'm not going to be able to Pluto. That's me. That's just me. There So, New Horizons arrives in 2015, and we saw a little bit about that fast ship, so we can skip it. It's 3 billion miles to them. Let me put on my best Carl. As we look up at their 3 billion miles. There's a little Carl Sagan for those of you that know. As it flies by, it'll take pictures of Pluto. Nothing's ever visited Pluto before. Nothing ever has. Probably for the next century, nothing else ever will. This might be our only encounter with this young planet in our minds. So recently, the Hubble Space Telescope was looking for things to do afterwards, and this was some stuff they found. They're looking for KBOs, which are Kuiper Belt objects, things past Pluto. Because once you go by Pluto, you got a perfectly good spacecraft heading out there. What else is out there? So keep looking. So they got some Hubble time. So let's actually look what we mean by this whole thing. Because when we say battle for a planet, what do we mean by planet? That's the really big trick question. Because nobody doubts that Pluto is a world. And it does pass some tests, and we'll talk about it, of course, it's a world. So let's know what we mean by planets. In the inner solar system, we have our 4 terrestrial planets, Mercury, Venus, Earth, and Mars. And you can see Mars ain't that big. Neither is Mercury. Venus is almost the same size as the Earth. But when people want to go to Mars, they're thinking, oh, so there's an interesting thing about Mars is that, well, Mars has got 1/3 the gravity. What's your weight now? Don't say it out loud. Multiply by 0.4. That's your weight on Mars. Less than half your current weight. Want to lose some weight? Move to Mars. All right. But if you want to gain some weight, if you really feel like you want to bulk up and get that protein shake going, go to Jupiter instead. Jupiter has 1,000 planet Earths could fit inside Jupiter. Jupiter's enormous. All the planets in the solar system, all the comets, all the meteors, everything except the sun. Add them up, it's not 1/3 the mass of Jupiter. Jupiter's the biggest thing in the solar system, beyond anything else. So it's the king daddy. And here's how big Saturn is, and that's Uranus and Neptune. Uranus. Yes, Uranus. Not the other one. We're not in 6th grade here. Okay, so. I am. Good for you, Leslie. So it wasn't 6th grade. Yes, there we go. Excellent. So here's all the planets on the screen to their correct sizes. Look at that. Look how different they are inside. Look how different they are in shape. Wait. Oh, wait. I can skip past that. So anyway, so what's really a planet? What do we mean by planet? It's a really really good word, because nowadays we have one way of thinking about planets, but let's look at this one. This is our current view. That's right. It's a planet if you can beam down on it, if you can land a firefly on it, if you can go there, if Doctor Who can get out, or if Kirk and Spock can walk on it, it's a planet. And in a lot of people's ways, this is what we really think about planets. This is what we really think. Consider this. Just think about all those episodes of Stargate where they get out on a planet. So let's take it back. That's our current view. And that's the thing that came about as a result of the space race, of going to the moon, of sending things to Mars, sending things to the outer planets. What do the planets really mean? For the Earth, for most of human history, only thing a planet was is planetas, the wanderers. If we were to watch these stars in the sky, and without a telescope, having no telescope prior to 1609, we'd look up in the sky, and we'd see most of the stars staying fixed, rising in the east and setting in the west. Every season they change, and we have one different set of stars after another. But some of the stars don't stay put. They wander in the sky. So the word planeta means wandering stars, or the wanderers. They're the wanderers. That's the real definition of a planet according to the most ancient definition. By that definition, the sun and the moon are planets too. In fact, they are, according to classical thinking. The sun and the moon are planets. In classical thought, because they move in the sky, right? So they're planets. So the wanderers can appear in many different ways. There's Venus over Turkey. There is the Orion over the Four Corners region. And if you ever get out to a truly dark sky, yes, you see this. Plug. Go out to a dark sky. Why? Most people have never seen one. Why? The lights are too bright. Go to someplace dark. See it. Jupiter over Ephesus, and Saturn over wow, what the heck is this one? Over a wonderful lake. And well, there's the Earth compared to the sun. So the sun is everything in the solar system. So when you say, oh, we're going to go to this place, well, the sun is most of the solar system. In fact, 99.9% of the mass of the solar system is in the sun. 1 million Earths could fit inside the sun. There's a lot. It is a lot. So why do we bother? Because new things in the sky make us look for new things. Look at that. Comet Pan-STARRS, last March, in the sky. This is over Oceanside, California. See what that is in the sky next to the moon? A little fuzzy thing with a little fuzzy tail. That's a comet. They appear out of nowhere, apparently. They grace our skies and they move on. They're the ultimate of the wanderers. At least the wandering planets, you knew what they were going to do. And all of the astrologers, including Mr. Galileo and Mr. Kepler, just threw on the bus, didn't they? Yeah, they actually cast horoscopes. But they did. They did that for money. They weren't dumb. So, anyway, but nobody could cast a horoscope based on a comet. And so comets were always thought of harbingers of doom. But Comet Pan-STARRS recently is. So here we have Comet Pan-STARRS over Toronto, Comet Pan and Comet Hayatake. Sometimes you get beautiful images like these where you have these beautiful tails. There's the coma, and then you have the tails. There's two tails, one made of ions and one made of dust, as the comet breaks apart. And Comet McNaught in 2007, yes, it really did look like that in the sky. This is just a camera on a tripod taking a picture, no magnification. It's enormous these days. Sometimes they look gorgeous like this too. But comets have been considered evil things, forebodings in the sky, harbingers of doom, pestilence, plague, everything, and in fact sometimes it caused divorces. So the thing is about looking up in the night sky, we sometimes see things that are new. So when you look at a comet and you say, what the heck is that thing? We want to investigate and learn more. So it sometimes makes us want to look out in the sky and see what's really going on. Back in the 1700s, late 1700s, William Herschel built some of his own telescopes. He ground the mirrors by hand. He had a very large telescope that he and his sister Caroline ground by hand, and it took him 72 hours to do it. He couldn't sleep, he couldn't stop, because if you stopped, then as you ground the mirror by hand, it would cool off and then take that shape. So he had to do this with sand and water for 72 hours while his sister Caroline fed him bananas and fruit to keep him awake and sang him songs. And basically said, oh, you missed a song. But they were an amazing pair. I should not be little Caroline until she was considered the first woman astronomer ever in the history of astronomy, and in fact won numerous accolades and awards. She is a person of deep note, and she and her brother are considered to be the two of the greatest minds in physics of recent time. So, in addition to discovering Uranus, as they were looking up in the sky, many people started seeing all these little rocks out there, asteroids. What are asteroids? Well, an asteroid is a funny little thing. Well, we see them as this. This is a Hubble image of the Ceres was discovered in 1801. Hubble image. Pallas was discovered in 1802. Juno, 1804. Vesta, 1807. A bunch of these things. So by the 1860s, there were hundreds of objects that had been discovered by astronomers, and they were all called planets. Why? Because they were all wandering in the sky. They were all lights in the sky that moved with respect to the background stars, and they were all over the place. So if you were a sixth grader in 1860, you had over 200 things to memorize. That was hard. So that wasn't any good. So they were, and what to call them was an active subject of debate. The U.S. Naval Observatory used the word minor planet, others used asteroid, others used star. There were lots of names for these things, but nothing was agreed upon in the literature. Then came along a very interesting fellow I just love. I love James Chalice. Look at that guy. He's got some serious attitude. He's ready for his profile on Facebook. And what it was is that Neptune was discovered not by accident the way that Uranus was. Uranus's orbit was plotted, and people knew where it was going to be in the sky, because once you know how things move, the lines move, you can check and see how good your predictions are. Well, Uranus had some bumps in its predictions. People weren't really sure where it was in the sky, and there were some perturbations to its orbit that couldn't be explained. But they said, wait a second, if there was another planet further out that we haven't seen yet, it could be yanking on the other's orbit and moving it. And that's how Neptune was discovered, in that exact way. And in fact, once it was established where it was, the German astronomer Johann Galle actually used Leverrier's prediction. The first night out, walked outside his telescope where Leverrier said it was going to be, and there it was. And he published and said, I found it. But it was according to exactly what Leverrier pointed out. But don't tell this to the French or the English, because there's still a debate over who really discovered it. Was it James Chalice? Was it John Adams? Was it Johann Galle? Everybody's fighting in all of these places to say who really discovered Neptune. And to this day, there are people in these camps who argue who did. Well, at the end of the 20th century, we had a whole bunch of things that we now call asteroids, which were in between the orbit of Mars and Jupiter, and we had the planets. And poor little Pluto's down here somewhere, I think. But the idea was that up until very recently, everybody had little Pluto in their books and their things. And they said, look, Pluto's the weird one. Orbit's tilted, it's farther out, it comes inside of Neptune's orbit, it's really small, we know it's not a gas giant. It's not big enough to tug on Neptune. What's going on with poor little Pluto? Well, where did it get discovered? Well, this guy, Percival Lowell, yeah, he figured that Neptune, he also found that Neptune had some perturbations in its orbit, and he said, well now, after looking for canals on Mars my entire life and not seeing them because, I was only seeing the reflection of my retina on the inside of the lens, the canales of Mars, which were actually a problem that were brought about by Italian astronomers who thought, oh, these are just channels that we see, and canale in Mars doesn't mean waterway, it might mean just lines. So Italian astronomers prior to Percival Lowell said, these are channels. And Percival Lowell said, water! There's got to be water, because there's Martians, right? We want to see the Martians. But he never saw them. He only saw the blood vessels in his retina reflected on the eyepiece. So, after failing at that, he decided to hunt for this planet gorgeous place, and my family lives down there, so I've been there. And there's Percival Lowell at the telescope in the 1920s looking for Mars. Well now, here's the thing. This isn't what astronomers do. That image is what everybody thinks astronomers do. Oh, you go outside and stare at the sky. That's what you do. And when you see something, you say, that's made out of X, or that's that far away by seeing it in the eyepiece. Thumbs down. That's not how the science is done. Nobody does this. Not one person who's a professional astronomer does this. In fact, there are people who study exoplanets and looking for them who've never even looked through a telescope. There are many of them that don't look through telescopes at all. That's a funny thing. There's more to that. There's a lot more to that. But this man did look through telescopes. Clyde Tombaugh was an avid amateur astronomer. He built scads of telescopes. He lived on a farm. He built this telescope out of an acetylene tank, an old axle from one of his tractors, and a whole bunch of gears to actually make it work. He's an ultimate DIY guy. He put this stuff together, ground the mirrors together, took old parts out of the barn and made a telescope. Made zillions of them. If you look at the stuff he's done, I visited his house. Oh God, the stuff he had in there was like, man, what do you do with that? It's like, I don't know, sell it on eBay, couldn't sell it. But funny thing is when he discovered it by using a machine that he built at the observatory. So he was hired to go down there because he drew the sky so well by hand that he was invited to take this job that Percival Lowell was trying to redefine the time X. So he built this, the blink comparator, where he took two images, separated them a week apart, and then blinked them back and forth just like a viewmaster. Before, after, back and forth, back and forth, back and forth. He did this for years. A long time. He met his future wife during this time, and he could only go on dates during full moons. The blink comparator is the way that he actually saw it. So can you see where Pluto is? That's the discovery image of Pluto. The little arrow on the left, January 23rd, 1930, January 29th, 1930. There's the little dot. That's what he saw. One little dot moving left to right. One little dot. Photographically, that's a tricky call. Now, when Clyde was doing this, and I talked to him, he was one of the most avid observers of the sky, taking photographs of more of the sky than pretty much any other astronomer of his day. He took pictures of over 70% of the night sky. Enormous pictures. He actually discovered galaxy clusters before people thought they existed. And when he talked to people about this, they said, oh, but you don't have a degree. So guess what? We're not going to trust you. But then very soon after, everybody says, oh yeah, galaxy clusters are really there. He said, I told you that. Because I saw them. I took pictures of them. They come in clusters. He was very funny. He was very ornery. And that's what he looked like when I met him. And Herb and Rita Beebe are off to the right. They're in the faculty at New Mexico State. They're still there. Clyde was given two absolutely horrible puns when you went to his office. You have no idea. Every other line out of his mouth was a pun. And in fact, this was a pun that he loved to show. It's how do you discover Pluto? That's how you discover Pluto. And the guy in the blue sleeve shirt, that's my advisor from undergrad. But he was in grad school in New Mexico. He went to grad school. He sat in the same desk that I sat in when I went to grad school in New Mexico. And he left a note under the desk saying, whoever that sits in this desk is cursed. And I didn't discover this until the third year when I was just getting out with my master's degree instead of my PhD. I said, John, why'd you do that to me? Because I lost my calculator within 2 weeks of arriving in New Mexico. And I found it just as I was leaving and found the note at the same time. So he cursed me by making me use my calculator for 3 years. Well, John's a funny guy. And so is Clyde, and there they all are. This is, this guy right here is, I think that's Alan Hale, of Gilligan's Island fame, but also Hale Pop fame. And this guy over here on the right, his name is, and there's some funny names in astronomy, just like there's funny ways of talking. His name is Hunt Guitar, and he's a great teacher. Hunt Guitar. So just the facts on Pluto. Pluto is good. Always we get down to the numbers. Because here's what we do with the scientific endeavor, and this is the most important thing. We can Anybody can make up any story we want about anything. That's legal, it's A-OK. But every story in science must be tested against experiment and must be verified. So what we call stories in science are called theories, meaning you put together a story surrounding facts and ideas, and those stories then have to be supported by the evidence, which are observations. So these are some of the senses of some of the observations that have been found about Pluto in the time known. Notice that the surface composition of Pluto is mostly water, which is a lot of things. Pluto also has a radius of about 600 or 700 miles. That's not that big. It's a little place that could fit inside the state of Texas. That's a crazy thought. In fact, it's farther across Texas than there. I've driven the 900 miles for a long time. So notice the day of Pluto is 6.39 Earth days, and the orbital period of Charon is the same. They orbit like this. The Earth and the Moon go like this, but the Moon tugs under it a little bit. But Pluto and Charon do this in the sky. They orbit each other. Their center of mass is not in Pluto. Charon's a big thing. It's like a dumbbell in space. Barbell being gravity. So Pluto's orbit takes it above and below the